Okay, so we're going to work on some compound interest here. Now, for the compound interest, we're going to be looking for our accumulated amount. And in this example, we're going to look at the case where our principal investment, now we're making one investment over a period of time. It's going to be $25,000. And we're going to be looking at T is equal to a 7-year period. And R is going to be equal to 5% in this example, which is the same as 5 divided by 100, or 0.05. Okay, so we have that over here. Now what we're going to have is we're going to have two formulas. One formula is going to be where we're compounding so many times a year. And for that, we're going to use the formula A is equal to P times 1 plus R divided by N raised to the N times T. And that's going to be our first case we're going to handle. And specifically, we're going to look at the case where we're compounding semi-annually, or twice a year, which is N equals 2. So this is the number of times a year we actually compound our interest. Now, at the end of the video, I'll talk about why this formula makes sense and where it comes from, just to show you. And for our second case, we're going to do continuously compounding. In that case, the formula is A is equal to P times E raised to the RT. Now, E is a number. Not all numbers can be written down because their decimals go on forever, kind of like pi. E is a number like pi, but it's an important number like pi, and it pops up all the time in math. And we can't write it down, so we give it a symbol. And where does this number come from? Well, you can approximate this number like you can pi if you take a huge value of n and you stick it into this formula. So if you take like n equals 100,000 instead of n equals 2 and you plug it in this formula and you calculate A, it'll essentially give you the same number as if you just use this formula to calculate A. So, alright, so that's kind of the connection between the two. To go between these two formulas, you need a little calculus to formalize it, but the idea is if you pick a huge value of n, think about if you're compounding all the time, every second of every day, say n equals 1 billion or whatever you would need, you essentially get this formula here. Okay? Where does this one come from? Well, it's pretty simple too. We'll talk about that after. But let's look at the first case. So for case 1, we're going to have the accumulated value after 7 years is equal to the principal investment, which is 25,000 P, right? Times 1 plus the interest rate R, which is going to be 0.05, divided by N, which is equal to 2. And it's raised to the N times T. Well, T is equal to 7, and R is equal to 0.05. Oh, I'm sorry. And T is equal to 7, and N is equal to 2, and we're raising to the N times T. Notice this is R times T over here, this is N times T over here, so we're going to have 2 times 7. So this is going to be equal to 2,500 times 1. Now 0.05 divided by 2 is going to be 0.025. And we add 1 is going to be 1.025, because 0.0 divided by 2 is 0.025, plus 1 gives us 1.025, raised to the 14, because 7 times 2 is 14, and 1.025 raised to the 14, if I do it in my calculator, is going to be 1.41297. So this is going to be 25,000 times 1.41297. Notice I have to raise this number to that exponent before multiplying by 25,000. 2,500. I'm sorry, 25,000. Okay? Because we always have to consider exponents before we consider multiplication. So we have to do 1.025 raised to the 14 before we do any multiplication by 25,000. Alright, so if we multiply these two numbers together, we wind up with $35,324 and a quarter. Okay? Okay, so let's compare that to the continuously compounding. Now, instead of letting n equal 2, if I were to let n equal like 100,000, say, not even that much, you're going to see the answers are going to be very close, even with n equals 2. But if we pick a really, really big number for n, like say 100,000, and just use this formula over again, we get a very, very similar value to if we use this. But let's go ahead and we'll just calculate that, because we want to be exact, and the homework questions want you to be exact to so many decimal places. So we want to use this formula just to be accurate. So we're going to have A is equal to P, and P is going to be 25,000 times E raised to the R, and R is 0.05, times T, which is 7 years. Now T is always going to be in units of years, which is going to be equal to 25,000 times E raised to the 0.35. And if I do E raised to the 0.35 in my calculator, this is going to become 25,000 times E to the 0.35 is 1.41907, which is going to equal to 35476.75, which is approximately $35,476.75. So I do better with continuously compounding. But for compounding every second of every day and every minute, I don't do that much better. You might want to think about why. And if you have an idea on that, you want to shoot me an email or something like that, that's fine. We can discuss that. But it gives you something to think about. But notice that if we look right before we multiply by 25,000, the compounding part of the expression, or the unit compounding part of the expression, is 1.41907, where here is 1.412. So the first two decimal places, these two parts are already the same before we multiply by the 25,000. So we're really not doing that much better. And you'll notice here we get 35,400 and some odd, here we get 35,300 and some odd. So it's still, we did an order of magnitude about $100 or so. Okay, so I hope that answers everyone's questions. You might want to ask, okay, where does this formula come from over here? Well, let's say that we're compounding once a year just to make things simple. And if we compound once a year, then our accumulated amount in the bank will be the amount we initially invested plus the interest rate times the amount we initially invested. So this is our principal, and this is the amount of interest we earned on the principal. And if we're compounding once a year, this would give us the amount in our bank account after 1 year. But we can factor the P out and get P times 1+r. Now I'm going to go ahead and label this amount as called P1. or P prime. I'll call this P prime. All right. Now, if I reinvest P prime in the bank account for another year, I'll have A2 is equal to my initial investment for that second year, which is P prime, plus have the same interest rate, I'll assume, times P prime. Well, again, I'll factor out P prime, and I get P prime times 1 plus r. Well, P prime is equal to P times 1 plus r. So this is going to be equal to P times 1 plus r, which is P prime, P times 1 plus r. And I'm multiplying again by 1 plus r, which is equal to P times 1 plus r squared. And if I keep doing this over and over again, you should see that the same notion repeats itself. So after n years, my accumulated amount would be my principal investment times 1 plus r raised to the n. And if I'm compounding n times a year, then it's a very, very similar argument. This should be t. If I compound for t years, then this would be 1 plus r raised to the t, like this is 2 years, this is 2. Now, it's a very similar argument to extend it to if I have a compounding period of n, then it's just going to be a is equal to p times 1 plus r divided by n raised to the nt. Okay. So I hope that makes sense. And if you have questions for me, please shoot me an email. I look forward to hearing from you, and I hope you have a wonderful day.